USS Zumwalt DDG-1000 is one of the most futuristic warships ever built, and even in 2026 it still looks like something pulled straight from a science fiction movie. With its sharp angular hull, stealth-focused design, and advanced combat systems, the Zumwalt-class destroyer represents a radical shift in naval warfare technology. Unlike traditional destroyers packed with visible radar arrays, antennas, and bulky structures, the USS Zumwalt was engineered to reduce its radar signature so dramatically that on enemy radar it can appear more like a small fishing vessel than a 600-foot warship. That stealth capability alone changed how military analysts viewed the future of surface combat ships, but the Zumwalt program was never just about looking futuristic. It was built to test and demonstrate what the next generation of naval combat could become, combining automation, electric power systems, precision strike weapons, and advanced computing into one highly sophisticated platform. At first glance, the ship's tumblehome hull immediately stands out. Instead of flaring outward like most naval ships, the hull angles inward as it rises above the waterline. This unusual shape helps scatter radar waves away from enemy sensors, contributing to the ship's extremely low radar cross-section. The smooth surfaces, enclosed deck features, and hidden equipment all work together to maintain stealth. Even the exhaust systems were designed to reduce the vessel's infrared signature, making it harder to detect with heat-seeking sensors. When viewed from a distance, especially in rough seas, the Zumwalt almost disappears into the horizon because of its sleek profile and low visual clutter. It's a warship designed not only to fight but also to avoid being seen in the first place. The USS Zumwalt measures roughly 610 feet in length and displaces around 15,000 tons, making it one of the largest destroyers ever constructed for the U.S. Navy. Despite its enormous size, the ship operates with a surprisingly small crew compared to older destroyers. Traditional warships of similar size might require 300 to 350 sailors, but the Zumwalt uses extensive automation to reduce crew requirements to around 140 to 160 personnel. Advanced computer systems handle many tasks that once required large human teams, from damage control monitoring to machinery management and power distribution. This reduction in crew size lowers operational costs over time while also improving efficiency, though it does place greater reliance on onboard technology and system reliability. One of the most revolutionary aspects of the Zumwalt-class destroyer is its integrated power system. Instead of separate engines dedicated to propulsion and electrical systems, the ship generates massive amounts of electrical power that can be distributed wherever needed. This means the ship can allocate power dynamically between propulsion, sensors, weapons, and future technologies. In practical terms, it turns the destroyer into a floating power station capable of supporting energy-intensive systems that older ships simply couldn't handle. This design also prepares the Zumwalt for future weapons like high-energy lasers or electromagnetic railguns, technologies that demand enormous electrical output. Even though some of those weapons are still under development, the Zumwalt's electrical infrastructure was built with future expansion in mind. Powering the ship are advanced gas turbine engines that allow the destroyer to achieve speeds exceeding 30 knots. While raw speed is important, the Zumwalt's real strength lies in how quietly it moves through the water. Noise reduction measures make the vessel harder for submarines to detect, giving it another layer of stealth in underwater warfare environments. The ship's maneuverability and smooth ride characteristics also help improve operational performance in difficult sea conditions. Despite the unconventional hull design raising concerns during early development, testing demonstrated that the vessel could handle rough seas effectively while maintaining stability. The combat systems aboard the USS Zumwalt are equally impressive. The ship was originally designed with land attack missions in mind, meaning it could strike enemy targets deep inland from hundreds of miles offshore. Its peripheral vertical launch system places missile cells along the outer edges of the hull rather than clustering them in the center. This increases survivability because if one section is damaged, the entire missile battery is less likely to be disabled. The destroyer can carry a wide range of missiles, including Tomahawk cruise missiles for long-range precision strikes, SM-series missiles for air defense, and anti-submarine weapons. This flexibility allows the Zumwalt to adapt to multiple mission profiles, from surface warfare and missile defense to strike operations and anti-submarine missions. One of the ship's most talked about systems was the Advanced Gun System, or AGS. The Zumwalt originally featured two massive 155mm naval guns designed to fire precision-guided long-range land attack projectiles at targets more than 60 nautical miles away. The idea was to provide devastating naval gunfire support for troops ashore with unmatched accuracy. Technically, the system was incredibly advanced, capable of rapid automated firing and precision targeting. However, the specialized ammunition became extraordinarily expensive, reportedly costing hundreds of thousands of dollars per round. As the Navy reduced the number of Zumwalt-class ships from a planned fleet of over 30 vessels down to just 3, ammunition production costs skyrocketed, eventually leading to the cancellation of the guided rounds. Without affordable ammunition, the advanced gun system lost much of its intended purpose, turning one of the ship's flagship features into a major controversy. By 2026, however, the Navy has increasingly focused on repurposing the Zumwalt-class destroyers for new strategic roles, particularly hypersonic missile deployment. The USS Zumwalt is being modified to carry conventional prompt strike hypersonic weapons, making it one of the first surface combatants in the world capable of launching these ultra-fast missiles. Hypersonic weapons travel at speeds exceeding Mach 5 while maneuvering unpredictably, making them extremely difficult to intercept. This transition gives the Zumwalt a renewed mission and potentially transforms it into one of the most dangerous strike platforms in the U.S. Navy. Instead of relying primarily on naval gunfire support, the ship is evolving into a stealthy long-range missile carrier capable of threatening heavily defended enemy targets across vast distances. The ship's radar and sensor systems are another major highlight. The Zumwalt uses advanced multi-function radar technology capable of tracking aircraft, missiles, and surface targets simultaneously. Its integrated combat management system processes enormous amounts of battlefield data in real time, helping commanders make faster decisions during combat. The ship was designed around network-centric warfare principles, meaning it can share information seamlessly with aircraft, submarines, satellites, and other naval vessels. In modern warfare, information dominance is often just as important as firepower, and the Zumwalt was built to function as a high-tech command node within a larger naval task force. Inside the ship, the environment feels dramatically different from older warships. Automation and digital controls dominate nearly every area. Touchscreen interfaces, advanced monitoring systems, and centralized control rooms replace many traditional manual operations. Crew living spaces were also designed with more privacy and comfort in mind compared to older naval vessels, partly because smaller crews allowed for more available space. This reflects a broader shift in military design philosophy where crew efficiency, fatigue reduction, and long-term operational sustainability are increasingly important. Despite all its technological breakthroughs, the Zumwalt program has faced years of criticism over cost overruns and changing mission requirements. Originally envisioned as the backbone of a next-generation destroyer fleet, the program shrank dramatically due to rising costs and evolving strategic priorities. Each Zumwalt-class destroyer ended up costing several $billion, making them among the most expensive surface combatants ever built. Critics argued that the Navy tried to integrate too many experimental technologies at once, resulting in technical challenges and logistical complications. Supporters, however, view the Zumwalt as a necessary step in naval innovation, a platform designed to push boundaries and pave the way for future warship technologies. And in many ways, that's exactly what the Zumwalt accomplished. Numerous technologies developed for the class are